In this unit, we're going to study quadratic functions. We learned about factoring quadratic equations in the last unit, and we're going to look at their graphs and at the characteristics of them in this unit. So we're going to start by graphing. So we're going to graph, and just in case you're not sure what a quadratic function is, look at this equation here, and it's a quadratic because it has a degree of 2. So it's a power of 2, so that makes it a quadratic function. So let's look and see if we can decide what they look like. So I'm going to draw a table. So x, y is going to be equal to x squared minus 2x minus 3. And I'm going to start plugging in points. So I'll start with the easiest, which is 0. So we get that y is going to be 0 minus 2 times 0 minus 3. So that's negative 3. So that gives me the point 0, negative 3. Then I'll repeat for 1. So y is going to be equal to 1 squared, just going to square right there. 1 squared minus 2 times 1 minus 3 is equal to, that's 1, minus 2 is negative 1, minus 3 is negative 4. So that's going to give me the point 1, negative 4. Now I'm going to repeat this. I'm going to plug in a 2, a 3, a 4, and a 5. So I'm going to stop this for a minute. You try it and then turn it back on. Okay, at this point, I'm stopping. I plugged in a 5 and I ended up with a y value of 12, which is off my chart. So then I'm going to start plugging in some negatives. So I'll start with a negative 1 and do negative 1 squared minus 2 times negative 1 minus 3. And I will continue with that. So I'm going to stop it again and do a few more until I get to the stopping place. Okay, so here we go. I've substituted my last one. So now I'm going to plot those points. So I have 0, negative 3. I have 1, negative 4. 2, negative 3. 3, 0. 4, 5. Then I have 5, 12, which is off. Then I have negative 1, 0, and negative 2, and 5 again right there. So you can kind of see the look. You can see there it's going to be a parabola. So it's going to be a curved shape, not a bunch of straight lines. So we're going to curve it as best I can here. So curve, turn it, and go back up. And here I have the shape of my parabola. We can do this again with the graph of y equals negative x squared minus 4x. We'll make a table and we'll plug in values starting with 0. There's a lot of minuses in this problem, so you'll need to be careful about that. So I'm going to stop it and draw my table right now. So the first point was really easy when I plugged in the zeros. I'm just coming up with 0, 0. So let's try now with a 1. When I put a 1 in, I have the minus sign, and then in place of this, I have minus 1, and the 1 itself is squared, minus 4 times 1. So this is going to be a negative 1 minus 4, which is negative 5. So I get the point 1, negative 5. So with a negative 2, I'm going to have a negative of 2 squared, which is negative 4, then minus 4. Ooh, I don't know why I put a negative 2 in there. This is really plus. So I get minus 4 times 2, and then that's going to be a negative 4 minus 8, which is going to be negative 12, which is off our chart. So then we're going to go back and put in a negative 1. So that's going to be a negative of a negative 1 squared minus 4 times negative 1. So that's going to be a negative 1 plus 4. So that's going to be 3. So that's going to give me the point negative 1, 3. Then we'll do a negative 2. So that's a negative 2 squared minus 4 times negative 2. So that's going to be a negative 4 plus 8. So that is 4. So that's going to give me the point negative 2, 4. One more, negative 3. Took a negative 3 squared minus 4 times negative 3. So that's going to be a negative 9 plus 12, and that is a 3. So I'm getting negative 3, 3. We do another one, negative 4. So negative of negative 4 squared minus 4 times negative 4. So that's going to be a negative 16 plus 8 is negative 8. So that'll be what? Negative 4, negative 8. Let's plot them. We have 0, 0. We have 1, negative 5. We have negative 1, 3, 3. We have negative 2, 4. Then we have negative 3, 3, and negative 4, and negative, my 8 must be wrong right there, because I'm thinking it should be negative 5. So what do we have? Negative 16, plus 16. That's a 0 actually, isn't it? So this should be 16. You can see where I'm changing that down here at the bottom on my chart. And that's going to make this be a 0 right here. And so negative 4, and that's a 0. I think we could have done negative 5 as well. And if I can come down, I'm going to have negative 5, so this would be a negative of negative 5 squared minus 4 times negative 5. So it looks like it is going to be a negative 25 plus 20, which is going to be negative 5. So I'm getting the point negative 5, negative 5, and we'll plot that right here. So again, we can connect those dots and come up with our parabola. All right, so let's define everything officially. A quadratic function of the form y equals ax squared plus bx plus c has a graph that is a parabola. The graph has a vertical line of symmetry that passes through the vertex. And that is either the high point or the low point of the graph. So here on our graph over here, this spot right here is the vertex. It's the low point in this case. The axis of symmetry comes right down the middle, crossing through that vertex, and splits that parabola in half, where it's the same distance to the right as it is to the left. So this is our axis of symmetry right here. Now we're going to talk about a few other characteristics of a graph. One of them that we talk about is the y-intercept. You know, we talked about the y-intercept of lines when we studied lines. We'll talk about also the y-intercept of our parabolas. So remember that to find a y-intercept, that is the spot where x is going to be equal to 0. So since x is 0, we'll say that y then is equal to 0 squared plus 4 times 0 plus 3. So we'll just plug a 0 in to our equation over there and get y is equal to 3. So my y-intercept then is the point 0, 3, and I'll plot that on my graph. There's my 0, 3 right there. Now it says find and plot the x-intercepts. We haven't really talked about those when we were graphing lines so much, but the x-intercepts can be found by letting y be equal to 0. So if y is 0, then I'm going to say that 0 is equal to x squared plus 4x plus 3. And again, plugging it into my equation up on top. All right, well, look, we're having to solve this now because we have a trinomial that we need to factor. So we use the short method. So that's going to factor two numbers that multiply to be 3. Would be 1 and 3. They add up to 4. So that's going to be x plus 1 and x plus 3 is equal to 0. You could also do the long AC if you want to. Then I'm going to solve it. So x plus 1 is 0. X plus 3 can be 0. So that means x is equal to negative 1 and x is equal to negative 3. So my x-intercepts then are going to be, there's two of them. There's negative 1, 0, and negative 3, 0. And I'll plot those on my graph. So negative 1, 0, and negative 3, 0. Then it says use the x-intercepts to to draw the line of symmetry for the parabola. So remember the axis of symmetry splits. It splits the parabola in half. So it's going to go down the middle. You kind of see here's these 2 points. There's the middle of them. It's going to go down the middle, exact middle of those 2 points right there. So this would be my axis right there of symmetry. So looking at where that axis of symmetry is, I know what the x value of the vertex is, because the vertex, remember, is on the axis. So we know that the x value of the x of this point is going to be -2, back 1, back 2. So what's the x value of the vertex? Well, that's going to be -2, because it's in the middle of those 2 points. And then finally, what is the y value of the vertex of the graph? And it says plot the vertex and finish the sketch of the graph. Well, to find the y value, since we know the x value is 2, we're going to bring that down and fill it in. Let's see what that original equation is. It's y equals x squared plus 4x plus 3. And if x is equal to -2, then y is going to be equal to a -2 squared plus 4 times -2 plus 3. So y is going to be equal to 4 minus 8 plus 3. So -4 plus 3 is -1. So my vertex then, which is on -2, is going to be -2, -1. And I'm going to plot that up here. So -2, -1, which is right there. Now, one more thing about parabolas, again, they're symmetrical. So you can see you've got the equal distance from each of these points. Same thing's going to be true here. If it's 2 to the right, it's going to be 2 to the left as well. So I have these 5 points that I can sketch in my parabola. All right, so we're going to do one more example. It's just like the last one, perhaps a bit more complicated with the 1/2 and the negative. I'm going to do that. I want you to give it a try yourself, and then you can check and see how you did against my work. All right, so plugging in x is 0, I come up with -6. So 0, -6, and plotted it. You may be wondering what to do when you start working on this x-intercept, because you have a -1/2 x squared. So remember that when we have an equation, so here's our equation right there. When we have an equation, we can eliminate the fraction by multiplying through by the common denominator. So let's come in here, and we're going to multiply through this by a 2. So I'm going to have 0 is equal to negative. Let's do -2. So then that makes it be 0 is equal to a positive x squared minus 8x, and then plus 12. And now go after that. So here are our x-intercepts, 6, 0, 2, 0, which I have now plotted. So we want to sketch the axis of symmetry that splits these 2 in half. So it's going to come down the middle here. So that tells me that the vertex is going to be on 1, 2, 3, 4. So x is going to be equal to 4 for our vertex. So use the x-intercept to draw the line of symmetry, which we did. What's the x value? 4. And then we want to use that to plug in and figure out what the y value of the vertex is. Okay, so I'm plugging it in to -1/2 x squared plus 4x minus 6, and I come up with that y is equal to 2. So if y is 2, my vertex then is going to be, let's see, the x we plugged in was 4 and 2, so 4, 2. So let's go back up to our graph and find the point 4, 2, which is right here. And then we can sketch it again. You can see right here, I have for that direction, so I'm going to go for this direction. There'll be another one over here to the side. So we kind of sketch this parabola in. This time, an example 5, the graph that we're going to be graphing is y equals parentheses x minus 3 squared, and then minus 4. So again, we're just going to repeat the same thing. We're going to find and plot the y-intercept, which means that we want to let x be equal to 0. So this time we'll have y is equal to 0 minus 3 quantity squared minus 4. So that's going to be negative 3 squared minus 4. So that's 9 minus 4, which is 5. So we have the point 0, 5 for our y-intercept. Now we're going to do the same thing. We're going to find and plot the x-intercepts. So that means that we're going to let y be equal to 0. So we're going to have 0 is equal to 0, should be an x. It's going to be equal to x minus 3 squared minus 4. All right, so this time, I need to figure out what this is, what x is. So we'll want to do some work that we've done before and maybe boil this out. So this is going to come out to be what, x squared minus 3x, so it's minus 6x plus 9 minus 4. So that's x squared minus 6x plus 5. So we boiled that or used a box method to do x minus 3 times x minus 3. And then that's equal to 0. Now we're going to factor it. So quick trinomial factor, AC method. That's going to be x minus 5 and x minus 1. So that means that we get 5 for an answer and we get 1 for an answer. So we have the point 5, 0 and a point 1, 0 for our x-intercepts, and we will graph those right there. So 5, 0, 1, 0. We want to then continue and draw a line down the middle to find the line of symmetry and figure out what the x value is. So here's the middle. So here's our middle of those 2 points. So we get that x is 3. And I'm going to finish that up, and you can finish that up and double. And this is what I get. We have that the x value is going to be 3. We're going to plug it into our original equation, x minus 3 squared minus 4. So I'm plugging in that 3 right there, and I come up with a negative 4 for my y value. So my vertex is 3, negative 4. I'm going to plot that 3, negative 1, 2, 3, 4, which is right here, and then sketch that in. So here we go. I guess we could do one more point up here. This is over 3 this way, so it's going to be over 3 this way. So we go here and get our graph. And I think that is it for today.